Thank you. In the summer of 1982, a 16-year-old boy spent the summer in his driveway figuring out how to jump into the air on a skateboard. Now this is pretty much the most basic trick in skateboarding. If you've ever watched people riding a skateboard, you've probably seen this happen. And if any of you wanted to leave right now, buy a skateboard, and learn how to do this, you could probably learn it within a week or two. It's a little complicated, but not too bad. The thing was, it took one person to figure out that this was even possible and how to do it. That guy's name was Rodney Mullen, probably my favorite skateboarder. He invented dozens of other tricks from very simple to advanced. For example, one of his tricks is called the impossible. So I wondered, are there similar things that we could learn in programming just by watching other people who have spent a lot of time really intent on improving their workflow, the tools they use, or just anything they've learned about actually doing programming? So I went various places around the world and talked to, not only talked to developers, but I actually sat down, gave them tasks that they could complete in about 90 minutes, filmed it, and at PeepCode we call this the play-by-play series. It's been very popular. And I want to share with you some of the best things that we've learned from watching other developers. So most of this talk will not be me talking, but it will be you hearing the voices of other developers talking about their own process. And to me, this has been very important because just reading the final source code of an open source application is not the same as watching it being written, and many things that can be learned by actually watching the process. So of the different people that we've talked to and adding more every month, they had many things to say, so let's start with tools. The most shocking thing I found out about the tools that these different programmers used was Vim. The majority of I didn't do this intentionally, but so many of them use Vim. Gary Bernhardt, first person we worked with before he was famous. Zed Shaw uses Vim. 2 days ago, I filmed with the keynotes of today, and both of them use Vim, Haynes and Patterson. Did I miss something? Is everyone supposed to be using Vim? I actually use Emacs, so I don't care what editor you use. But it was interesting. But maybe it isn't that important because your text editor isn't the only tool that you should use while you're programming, or it's not the only one used by the people that I talk to. Here's Ryan Singer, amazing UX designer at 37 Signals, but also a decent coder on his own right.
Is how to get that email address. Because do we want you to scroll through the 195 that you didn't pick? But I think we could probably figure that out. I'm not worried about it, so I'm not going to spend a lot of time sketching it right now. Like, I'm only sketching about stuff I'm worried about.
Yeah.
Right? Like, sketching, it's not like this is the process. First you sketch everything, and then you do it, and then, you know what I mean? Like, it's not like that at all. It's more like when you're worried about something, sketching can help you. Right?
It's another tool for us
figuring out the problem. It's just a medicine to the pain of worry. Like, I'm not confident enough to spend time in code because I think I can go down the wrong direction and I'm going to screw around wasting time. So I'm going to remove that worry by proving myself that my thinking is clear about what I'm going to do. But it doesn't mean that I have to sketch the whole app. I just need to sketch enough that I know what I'm doing.
So sketching was a big part of his process. I've enjoyed watching other people as they're listening to the lectures today, some of them taking notes on a computer, some just listening, and some sketching on paper. For him, it was great for me to watch how he was able to separate the different tasks or problems that he was trying to solve, and using the best tool for each of those, he spent out about an hour sketching through ideas on paper, and then an hour coding. But not everyone likes to sketch, and there are other ways to think through a problem. Here's Neven Mrgan, UI designer at Panic Software.
One reason I don't do so much sketching is that my equivalent of sketching on paper is making references to other things, basically. So if I say something like highway signage, in those two words I've described you exactly, like I'm sure we have the same image. You have the big green signs, or brown for like the parks and whatnot, that are sort of big round reds. They're made of that slightly shiny metal, so they're light at night. They have that inset white border around the thing, the very legible font, interstate or whatever it's called now. Like you get all of that for free if you just make a reference to the right thing. So that's kind of how I sketch, both in my head and when talking to other people, and I just sort of rely on the fact that most people are familiar with the same basic set of pop culture.
Both of these, whether it was sketching or using language to understand and think through a problem, it was impressive for me to see how they used this as part of problem solving and had really honed their skill in thinking about the different elements of a problem. For example, Neven specifically, I gave him a task, which was to design a UI for a trail hiking directions application. And literally within 2 minutes, he had thought through it, pulled apart the different elements that were going to be involved, and was able to express it as both highway signage, because these were directions, and a recipe, because there was some latitude as far as how exactly one chooses to go through the trails in a forest. And this way of thinking really showed me that he had this skill of learning to communicate about about what the problem was, and it was not only communication, but also part of his problem solving and thinking. But even with those tools, understanding the weaknesses of each tool is very important. Problems have multiple stages of thought. As developers, we often want to just dive straight into a text editor, but text editors are good for sequential ideas or very specific implementations, and sometimes aren't as good for undirected brainstorming. This is one of the things I love about refactoring, is it's a realization that satisfying the requirements for a feature is different from organizing your code. So these are two stages. One is just getting the code down, the tests pass, and step two is refactoring, and these are completely different things. So understanding the different stages of a process and maybe using different tools for each of those stages. But whatever you use for the different tools in your thinking process, know it well. Gary Bernhardt is incredible in his knowledge of Vim. I was actually sat with him working one day in a coffee shop, and someone came across the coffee shop and said, "How did you just do what you just did in Vim?" Like he's such an amazing Vim user that other people in the restaurant were astounded by what he could do. So here he is talking about that.
What I've just said is map comma t. Comma is my leader key, which is your key to play with in Vim for whatever purpose you want. The default is \\. I use comma. So every time I write comma t in normal mode, it's going to save the file, and then it's going to run bang spec, which is our spec, on the current file, which is %, and insert carriage turn at the end, so that it actually is a command to Vim.
It's interesting to me that he, and I asked him about this, well, why didn't you write a script to just automate run, there's code out there to run tests for the current file, but he was much more comfortable customizing it as his editor all along the way. That gave him the fine-grained level of control that he wanted. Sometimes, though, I wonder if maybe Gary overthinks things a little bit too much.
You used visual mode there to highlight a couple lines and then to Vinum, right?
I did. I
Isn't
didn't
that
say
the whole point of Vinum? 2db?
Well, so what you're suggesting is 2db. What I actually did was visual line mode JDE. It's the same number of commands. Now I do have justification here. If you look, unfortunately I'm using QWERTY layout. I used to use Dvorak, but I switched back. And I think you're a Dvorak user, right? So this won't apply as much to you, because J is all kinds of inconvenient on Dvorak. But anyway, if you look at 2db on a QWERTY keyboard, you're reaching way up to 2, which is 2 rows above home. That's bad. So that's the 2. And then DD is the same key twice, which is actually slow. When you are really a quick typer, hitting the same key twice is slow. if you look at Shift V JD, Shift V is easy for me. I do a lot of shifting. And V is a little inconvenient, but then JD is both home run. So overall, I think this is a faster keystroke.
Another thing that really made me think was the way that some developers think of not only of the primary purpose of any particular tool, but the way that we actually use it every day. Here's a controversial figure who I appreciate many of his ideas, Zed Shaw on source code control.
Like, I very rarely commit stuff to the wrong branches. I'm just very careful. I'm like, okay, so this should go in there. I think that comes because everyone else thinks of source control tools as code backup. And I think of it as code talk, like communication. I'm communicating with someone else, so I gotta make sure that it's a good message, right? Like, if I spend time writing an email, I spend time writing this. So I make sure that it has a good commit message, same like I would do a subject. Hey, person who's reading this is why you should read this. And then I make sure that it's going to the right place, like the right address, what branch is it? And I've got, the same things you do with email, I do with my code tools, And then, so that's pretty universal. I mean, if I use HG, I use Git, I do the same thing.
That really changed my idea of what a good commit message is, and the idea that, yes, Git is backup. I use several computers on any day of the week, and it's nice to have access to my code, not to mention giving it to other people, but communicating about what I did, that's a more real effect of source code control. That's how I actually am affected by it every day, and that's definitely part of Zed's workflow. Well, we talked about tools. How about workflow? How do people go through solving the problems of programming? Well, since this is a Ruby conference, to learn to write Ruby code, I figured there's no one better to watch than a Ruby committer. So here's what it sounds like when a professional Ruby committer writes Ruby code.
What? Come on. Come on. Come on. All right. All right. We need more tests.
That's Aaron Patterson, who you will hear later today. So workflow, the first major obstacle, the one thing I learned from watching these developers is that the first obstacle is to figure out just what the problem is. Often we think that is obvious, but that's if you overstep this question, what is the problem? That's going to be a problem in itself. Here's Gary Bernhardt again.
Right, and one thing you have to do when you start building software this way is suppress the programmer's tendency towards hubris. To say, I know what this data structure is, I know it looks like this, because the thing is, if I'm doing this stubbing, right, should receive, if I stub it out, and then I write my assertion based on that, and I stub it out wrong, how do I know, right? I haven't written the integration test yet. So what my uncertainty here tells me is that I should not be writing this yet. I lack the knowledge, and I need the integration test to help me.
This is one of the things I love about TDD. It's not just about the final product, the code that we end up with. It's also about the process and how we write the code and how we think through the problems. And part of understanding those problems is understanding the context. This again is Ryan Singer, who spends most of his time thinking about user interface issues, but I think what he's about to say is useful for back-end developers, database designers, sysadmin individuals, all kinds of people. Context.
It's not helpful to look to think of UI as being only the screen level, because every screen that you're looking at you have to get there, and then you want some result. You know, so I always try and take any kind of screen that I'm working on, and before I dive really far into the details of the screen, I want to split it up into beginning, middle, and end, or like, you know, past, present, and future, or whatever, like these three, because then I'm aware that I need to get into it somehow, and then I'm also going somewhere, and then thinking through that process, I'm able to think about, for example, the fact that, like, in order to do these things, I need an email address.
This concept of context is super useful and has changed the way that I go through thinking about problems and writing code. You know, data, where is this data coming from? How is it created? How long do we need it? What's going to happen when it's time to destroy it? What's that whole life cycle of this data? You know, persistence of data, network, things, you know, any kind of connections to other services. The context around all of those things are a useful thing to think about when you're solving these problems. Now, that's a fair, once it's said, that's a fairly obvious workflow tip. Some workflow styles of individuals are not quite so obvious. Zed Shaw will occasionally delete his entire project and start over if he's interrupted.
So yeah, so the thing that I try to focus on is you pick one thing, you have a to-do list. So you have a list of crap you're supposed to do. Pick one thing, you start working on it, try to find out if you've screwed it up early, right? Then if you have, ditch it. Work on the thing you actually should, you know? Or if your implementation is bad, ditch it. Just ditch it. It's code. It's not like you built a sculpture. And I'll take notes. Like before I ditch it, I'll like, oh, okay, so yeah, okay, I gotta go here, I gotta do this, or write on a piece of paper, like some stuff, or maybe I'll update that README file, or I'll update my little to-do list or whatever, and so I'm not totally ditching what I learned, but yeah, just toss code out. Anything I worked on, I'll be like, this is crap, or revert it. You know?
I do like the fact that he has the whole idea of improvement, of starting over again, of learning from the code you've written as part of his regular workflow. You know, we already have that in different versions of software. We want to make the new version better than the old version and learn from the different lessons. But if we can do that in agile fashion and bring that down to a daily, hourly part of the process, we can benefit from that as well. Distractions are probably the most harmful part of any workflow. Even after you've turned off Twitter, IRC, instant messaging, whatever, you can become distracted by the project itself. Here's Kyle Neath, designer at GitHub, talking about distractions in detail.
I actually like it because I definitely like a lot of experimentation, but I found that that's a really good way to kind of rabbit hole your project and start focusing on things that don't matter. And so I'm a huge fan of obviously shipping as fast as possible, and a lot of that means kind of giving up that even if you are good at making very pretty design, just kind of ignore that for the time being and solve the problem.
A way that I've seen this concept recently is the whole idea of persistence. Often if we're writing a web app, we want to just start thinking about where is that data being saved, and yes, that's part of the context. But as I've given various tasks to developers, more and more, they're starting to just think about the objects, the relationships, the functionality of those objects, and later down the line, then they think about persistence, which helps them to keep from being distracted by these little details that Kyle was talking about in the user interface. But overall, it's about finding the singular obstacle that will help make the other problems easier to solve. This isn't always the hardest problem, or even the first problem in the cycle. The nice thing about test-driven development is that we can implement code in almost any order. Even if you're not mocking and stubbing things extensively, you can write tests that express expectations about some part of an object's life cycle, and then later decide to implement the earlier stages or the later stages. And finding out where to start on a project seems to be a thing that experienced developers have learned to really think about and to do well. Well, let's wrap up with another skateboarding analogy. Great skateboarders have flow. They can find a line through 3D space and keep their momentum up, sometimes indefinitely. Going around a concrete swimming pool, they can change their course, they can create something new, but it's not something that they're thinking about explicitly all the time. There's a level of intuition, a level of understanding of physics, and how that works out physically. Of course, this is necessary. If you're hurling along toward a concrete wall, you don't have time to do calculations on paper. You just have to know what's happening next and how to react. I found that great programmers often are the same way, that yes, they're working on a specific problem, but they also have other concepts in the back of their mind that they're paying attention to. One of those is understanding that your first idea is almost always not your very best idea. Here's Ruby veteran Jim Wyrick.
So my big goal was to make it so I could pass this proxy object around as a user in a Rails app and no one would care, no matter where it was. If we limit it to, hey, we're in the controller, we're going to wrap the object with the protection proxy, and we call update attributes on that, and that limits the scope. We don't have to make it behave like an object everywhere for Rails. And actually, that's probably a safer thing to do. This whole time I was kind of wondering, will it really work with Rails or not? And it would have been kind of fun to explore that. But I think we kind of ran into a brick wall with that. So let's kind of scale back our expectations. I think we'll still meet your criteria, but we're just a little bit less ambitious. We're being agile, right?
Right.
In the few minutes previous to this quote, he had started adding quite a lot of complexity to the library he was writing, and it had to get more and more complex. And so then he got to this point where he realized that, he had this kind of timer in the back of his head, realizing that as this complexity piled up, that it was going to make the problem even harder to solve. And so he was able to scale back his ideas and try something different. One of the first books I read about programming was by Frederick Brooks, The Mythical Man Month, and one of the chapters that he has in there is that all programmers are optimists. Without it, you would probably become depressed over all the failed tests, the broken software, delayed releases. It's kind of inherent to making it in this industry that you have to be an optimist. But sometimes that makes us want to think that all of our initial ideas are the best and that we can just make them work at any cost. But sometimes our initial ideas are that first step that gets us to better ideas. This is part of the core concepts behind refactoring, refinement, iteration. These aren't only ways to make better software, but also an admission that the first idea we have may not be the best one. It's a starting point, but it's not the ending point. A nuance of that I found something great developers do is just having this idea of how long it will take for them to finish whatever they're working on right now. Here's Kyle Neath again.
And the opacity, what's being communicated there is that selected or unselected? Okay.
Just showing, again, I kind of want this to be not the real thing, but actually at this point, what I realize is I'm kind of going down a path that I don't care about too much. This is something that can be polished later.
Okay.
Almost to the point of if I just had this screen that just said every screencast, and instead of making this complicated thing, icons, I could just throw.
So he goes on from here, the concept being that he had an idea that if he kept implementing this certain idea, it was going to take a long time. Now, initially I thought, well, maybe this is a little bit artificial. The goal of these videos I was making was to give people about 90 minutes to work on something, and most of us have much more than 90 minutes to work on any single project, so maybe that was just artificial. But it turns out even in real life, we have budgets, we have time constraints, we have number of developers that can work on a project. And so there are definitely constraints on our time, and that affects what ideas that we can implement. And keeping some kind of concept in the back of our head of, am I going down a path that's going to take way more time than I have resources for? That's a key part of maturity as a developer. But to me, the most unexpected thing that I learned was not something I was looking for at all. And in fact, it took me 3 or 4 times of seeing different developers exhibit this before I realized what was happening. And that's being able to change course, to stop what you're doing halfway through, abandon the code that you've written, or the time you put in, or the idea that you're implementing, and see if you need to change course. Here's Tim Caswell.
Okay, let me just think about the algorithm. Stop typing. I think that's my problem. So I have the words. I just need for each type, I need a list of all the matches. That's all I need. Okay, this is easy.
Now that looks easy just to see. I mean, what, that was 20 seconds or something that he pulled his hands off the keyboard, even closed his eyes, focused. What you didn't see is that he spent the previous 5 minutes kind of wrestling this problem and adding lines of code and deleting and figuring out, trying all these different strategies, which, okay, 5 minutes isn't that long, but when he realized that he was going in the wrong direction and just took a moment to stop, suddenly it just took a few thoughts and a few seconds, and immediately after this, he wrote about 4 lines of code, solved the problem, it was done. This is it's a difficult thing because we need flow in our work to stay on task, to have momentum, to feel like we're making progress. But sometimes momentum works against us because if we have momentum toward a dead end or momentum that's complicating things or making it harder for us to think through a problem, that momentum needs to be stopped and we need to be able to turn around. It takes a lot of self-discipline, but it means that you can use what you've learned to solve the problem better, and as you saw there, sometimes getting away from the computer, using different tools, figuring out how that fits into our workflow. A common fallacy that is associated with this is called the sunk cost fallacy. If we put time and money into something, the more time and the more money we put into something, the harder it is for us to abandon any particular project. Take the example of, let's say, going to the movie theater and watching a movie. I pay for a ticket, I get into a movie, and let's say I discover that it's a horrible movie and I'm not enjoying the experience. Most people will think, well, I paid money for this movie, I'd better sit here and watch the entire thing. Well, that's the sunk cost fallacy. If you're going to cause yourself more pain, that's not going to salvage the money that you paid for this so far. It's better at some points either just to change course altogether, or in the case of here, try a different strategy to think through the problem. This is useful not only in programming, but also in life. So this is, these are some of the things we've learned at PeepCode from working with developers, and we're continuing to do it, and hopefully you have found that useful. I also, we're going to make a blog post soon where we list all the different projects that we've given to people, and I really hope that either you'll try these projects yourself or in a user group or a coworker. Try to do this kind of thing. Watch other developers writing code, watch other designers in their process, see what you can learn, and see what they can learn from you. Thank you.